And now I ask the first presenter, Holst Jensen from Biochemfusion.
Okay, thank you very much. And this talk is about taking you on a trip in sequence and structure space. Don't worry, not an acid trip, but an amino acid trip. So this is done in collaboration with Arcos GmbH in Germany. They are the people behind the global search engine. And first, a couple of words of what Biochemfusion, the problem that Biochemfusion is trying to solve. We have the world of cheminformatics and we have the world of bioinformatics. And the way Biochemfusion, the way I see the world, is that sequences are just another way of representing a molecule. So when the molecules grow big enough, it's convenient to use sequences. When you have them small enough, it's convenient to use an atom bond graph. And then you have those things in the middle where you want to view it both ways and switch back and forth. And previously, Biochemfusion has been able to work with chemically annotated sequences, so you can transform a sequence into a chemical structure. This year, I'm coming out with an improved algorithm that can take a chemical structure and map that back into a sequence. And let's see what that can be used for. This is the global search engine from Arcos. And it's based on using using the Marvin Sketch web applet for drawing a chemical query structure. And then you can submit that to a lot of public chemistry search engines on the web. In the upcoming version, when you go to the advanced search, there's a Protex button. And once you click that, you can just enter a peptide or protein sequence in 1-letter or 3-letter format. And this one is an oxytocin analog that I've entered. You see the disulfide bridges between the two cysteines, and it's got an amidated C-terminal, so there's a little bit of chemical modification in there. Then I've substituted glycines for position 3 and position 8, because I know that a lot of the cyclosporine analogs have substitutions in position 3 and 8. And normally when you ask Protex to generate a query structure for that, it will add explicit hydrogens to all the side chains so you get exact matches. But in this case, we'll configure the two glycines to be without explicit hydrogens, so you'll hit any kind of residue that's in those positions. So we go on. The structure was generated for us by Protex and put into the Marvin Sketch tool. And then you can go on and search, for instance, in PubChem. Let's do that, and we find about 100 hits. And if we go and look at those hits, we can say, oh, wow, we've got all these fuzzballs of molecules here. What are they? Like, it's probably something to do with oxytocin, but is it really? I mean, if you try to look at the names, like for instance this name here, is that oxytocin? Well, I can't tell, but now let's go and analyze this instead. So I'm using Excel because I tend to like it, and also because we have JChem for Excel, and there's also a Protex Excel add-in, the Biochemfusion software. I've used JChem for Excel to import the SD file, which represents all the hits we found in PubChem. And next, I'll use the new from JChem Structures functionality in the Proteax add-in. So if you have JChem Structures in your Excel sheet, you can just press that button and have that mapped into peptide sequences. That makes it a little bit easier to see what we have here. And finally, I've used the compare proteins function in the Proteax add-in. I added the standard oxytocin sequence here and asked Protex to compare all the results that I got from PubChem with oxytocin. And then I can instantly see that the first hit here is really just oxytocin with 2 substitutions, Position 3 has been replaced with phenylalanine. How do you say that in English? I don't know. And position 8 has been replaced with an arginine. And similarly in row 2, it is oxytocin, except you have the phenylalanine in position 3, and you have a lysine in position 8. So there you have it, a peptide SAR table. And you can also use that for in-house data, so you can do peptide SAR tables. So I'll just cut it short here, even though I'm tall, and leave you with a few links, and thanks.